We live in an age that feels fully charted. You can pull up a satellite image of nearly any street on Earth, track a storm forming over the Atlantic, or zoom into a mountain range you'll never visit and read the name of every peak. It's easy to feel like discovery is something that happened in the past. Like the blank spaces on the map have all been filled in. But here's what most people don't realize. More than half of our planet has never been explored. Not in any real sense, not up close, not with human eyes. The ocean covers over 70% of Earth's surface, and we've mapped less than a quarter of the seafloor in genuine detail. There are cave systems that descend deeper underground than skyscrapers stand tall, and scientists have only reached the bottom of a handful. Beneath 2 miles of Antarctic ice, lakes have sat in total silence for millions of years. And deep in the Amazon, entire river corridors exist where no researcher has ever set foot. This isn't ancient history. This is the world as it stands today. In this documentary, we're going to travel through 5 of the most unexplored places on Earth. Each one holds discoveries that are still unfolding, and questions that scientists are still working to answer. And in more than one case, what they found down there quietly changed how we understand life itself. Let's begin with the deepest place on our planet. A scar in the ocean floor so extreme, so remote, that it remained almost entirely unknown to science until the middle of the 20th century. In the western Pacific Ocean, about 200 kilometers east of the Mariana Islands, the seafloor simply drops away. What begins as a relatively flat stretch of ocean bottom suddenly descends into a long, crescent-shaped canyon, nearly 2,500 kilometers from end to end. At its deepest point, a place called the Challenger Deep, the ocean floor sits almost 11 kilometers below the surface. To put that in perspective, if you took Mount Everest and lowered it straight down into the Challenger Deep, the summit would still be more than a mile underwater. The entire mountain gone. The conditions down there are almost impossible to imagine from the surface. Pressure bears down at roughly 1,100 times what you feel standing in open air. The temperature hovers just above freezing, and there is no light whatsoever. The sun's rays dissolve long before reaching even a fraction of the way down. But the most surprising discovery about the Mariana Trench was never its depth. It was what scientists found living there. In 1960, 2 men descended into the Challenger Deep aboard a vessel called the Trieste, a submersible built specifically to withstand the crushing weight of the deep ocean. Jacques Picard and Don Walsh spent just 20 minutes on the bottom before a pressure crack formed in one of their observation windows, forcing them back up. But in that brief time, Picard reported seeing something moving along the sediment, what he described as a flatfish, drifting calmly at the deepest point on Earth. That observation sparked decades of debate. Some researchers believed it was a sea cucumber, not a fish at all. The argument went on for years, but the core implication remained. The trench floor was not a barren void. Something was alive down there, and what followed over the next several decades only deepened the mystery. Robotic probes and unmanned vehicles sent to the trench have returned footage that continues to surprise the scientific community. Giant single-celled organisms called xenophyophores, some the size of a dinner plate, have been found resting on the sediment. Translucent snailfish have been filmed at nearly 8,000 meters, drifting through the darkness with an almost dreamlike stillness. And swarms of tiny crustaceans called amphipods carpet sections of the trench floor in numbers that no one anticipated. When scientists analyzed those amphipods, they found traces of industrial pollutants in their tissue, chemicals that had filtered down from the surface world over decades. At the deepest point on Earth, the fingerprints of human industry had already arrived. In 2019, explorer Victor Vescovo set a new depth record in the Challenger Deep. At the very bottom of the ocean, he found a plastic bag and candy wrappers. This is where things become even stranger. In other parts of the deep ocean, researchers have discovered hydrothermal vents, cracks in the seafloor where superheated mineral-rich water rises from the Earth's interior. Around these vents, entire ecosystems thrive with no sunlight at all. Tube worms, blind shrimp, chemosynthetic bacteria that extract energy not from the sun, but from the chemistry of the water itself. Scientists believe similar vent systems may exist within the Mariana Trench, but they haven't been found yet. The trench has been visited by humans fewer than a dozen times. Most of it has never been seen, and the deeper researchers look, the more they find that what they expected and what actually exists down there are two very different things. The deepest place on Earth is also one of the least understood, and we may have barely scratched the surface of what it holds. The ocean floor is one kind of hidden world, but there's another kind buried not beneath water, beneath ice, miles of it, and what lies sealed under that ice has been waiting in complete darkness for longer than our species has existed. Antarctica is a place that resists easy description. The coldest continent, the driest, the windiest. It is larger than Europe and blanketed almost entirely in ice, a sheet that averages 2 kilometers thick and, in some places, reaches nearly 5. In winter, surface temperatures on the high plateau drop to minus 80 degrees Celsius, cold enough to freeze fuel lines, cold enough to shatter exposed metal, cold enough that breathing the open air without protection can damage your lungs. For most of history, Antarctica was treated as a surface problem, a place to survive, not a place to investigate beneath. But in 1974, a signal from deep within the ice suggested something no one had anticipated. Scientists analyzing radar data from aircraft flying over the East Antarctic ice sheet noticed an anomaly. In one region, the radar return looked wrong. Not like ice resting on bedrock, but like ice floating, ever so slightly, on something smooth and flat beneath it. Something liquid. The ice above that region was nearly 4 kilometers thick. Liquid water, at that depth, in one of the coldest places on Earth, seemed impossible. The explanation, it turned out, involved several forces working in combination. The sheer weight of kilometers of ice above lowers the melting point of the ice at the base just enough for water to exist in liquid form. Geothermal heat rising slowly from the Earth's interior adds a small but steady source of warmth. And the ice itself, all that mass above, acts as an enormous insulating blanket, trapping whatever heat accumulates below. The result is a subglacial lake, a body of liquid water sealed beneath the ice, completely cut off from the atmosphere above it. Scientists now believe there are more than 400 of these lakes scattered beneath the Antarctic ice sheet. 400 hidden lakes. And for most of human history, we had no idea any of them existed. The largest and most studied is Lake Vostok. It lies roughly 4 kilometers below the surface of the East Antarctic ice sheet, and it is comparable in size to Lake Ontario, about 250 kilometers long, 50 kilometers wide at its broadest. By volume, it is one of the largest lakes in the world, and it has been sealed from the outside atmosphere for somewhere between 15 and 25 million years. To hold that in mind, 25 million years ago, the first recognizable ancestors of modern humans had not yet appeared. The continents sat in slightly different positions. The climate of the planet was a different thing entirely. And Lake Vostok has been sitting in darkness, untouched, since before all of that. In 2012, a Russian team that had been drilling toward the lake for over 2 decades finally broke through to its surface. The drill was designed to minimize contamination of the water below. What came back, traces of microbial life preserved in the ice just above the lake's surface, immediately sparked debate within the scientific community. Were those microbes genuinely from the lake, or had they been introduced during the drilling process? That question has not been fully resolved. A smaller lake, Lake Willans, beneath the West Antarctic ice sheet, was sampled in 2013 by American researchers using a hot water drill designed for cleaner access. The results were less ambiguous. They found a rich community of microbial life, thousands of distinct species of bacteria and archaea, living in total darkness, drawing energy from the minerals in the surrounding rock and water. No sunlight, no photosynthesis, just chemistry and geological time. What this means extends well beyond Antarctica. Jupiter's moon Europa and Saturn's moon Enceladus are both believed to have liquid water oceans beneath their icy surfaces, kept liquid by tidal forces from their host planets. The environments in those hidden oceans may be remarkably similar to what exists beneath the Antarctic ice right now. Antarctica's buried lakes may be the closest analog we have on our own planet to an ocean on another world, and we've barely begun to explore them. We've descended into the ocean and traveled beneath 2 miles of polar ice. Now we move somewhere that feels entirely different, a place bathed in sunlight, overflowing with life, and in some ways, just as unknown. But the question this chapter raises is one of the most unexpected in the documentary. So far, we've explored places hidden beneath the ocean and beneath kilometers of ice. But some of the least explored places on Earth aren't hidden underground at all. They're hiding in plain sight, covered not in water or ice, but in trees. The Amazon basin covers roughly 7 million square kilometers. That's nearly twice the size of India, spread across parts of 9 countries. It holds an estimated 10% of all species on Earth. Scientists have been studying it for centuries. Satellites image its canopy continuously. Research stations operate along its major rivers, and yet the vast majority of it has never been explored, because a satellite image shows you a roof. It tells you almost nothing about what exists beneath it. The Amazon operates on multiple vertical levels, each one its own world. The tallest trees, emergence, punch through the main canopy and reach 40, 60, sometimes 70 meters into the air. Their crowns in full sunlight, while everything below lives in perpetual shade. Beneath them, the canopy layer forms a dense, interlocking ceiling, where most of the forest's birds and primates spend their entire lives. Below that, the understory. Dimmer, more humid, adapted to filtered light. And finally, the forest floor, where fallen organic matter decomposes almost as fast as it lands, and where fungi thread the soil in networks spanning entire hectares. To explore the Amazon in any real sense requires entering it on foot or by small boat, slowly, carefully, for extended periods. And for the vast majority of the basin, that simply hasn't happened. Every year, researchers entering previously unvisited areas return with species that have never been recorded by science. In a recent single year, more than 2,000 new species were described from the Amazon region alone: plants, insects, fish, fungi, reptiles. Some had been known to indigenous communities for generations. Others were genuinely unknown in any form. The fish diversity of the Amazon River system is particularly striking. Scientists believe more than 3,000 species of freshwater fish exist in the basin. That's more than in the entire Atlantic Ocean. New ones are still being found in remote tributaries that researchers are accessing for the first time. But the discoveries aren't only biological. For a long time, the dominant assumption in Western scholarship was that the Amazon had always been sparsely populated. that the poor tropical soils couldn't support large, settled civilizations. That assumption has been fundamentally overturned. LiDAR technology, which fires laser pulses from aircraft to map terrain through tree cover, has revealed roads, earthworks, plazas, and land use patterns hidden beneath the canopy. Pre-Columbian societies of considerable scale once lived and built in the Amazon, and the true extent of what they created is still being uncovered. In some regions, the forest itself appears to have been deliberately planted and shaped by the people who lived there, centuries before any European arrived. There are also communities in the Amazon who have chosen to remain entirely uncontacted. Indigenous peoples who are aware the outside world exists and have actively decided not to engage with it. Brazil officially recognizes these groups and maintains a strict non-contact policy, in part because outside contact has historically brought diseases to which these communities have no immunity. Their numbers, their languages, and the depth of their knowledge of the forest remain unknown to the outside world. In the western Amazon, near the borders of Peru, Bolivia, and Brazil, entire river systems have rarely or never been visited by researchers. The species that inhabit them, the plants that grow along their banks, the ecological relationships that have developed over thousands of years, all of it exists in an undocumented state. Meanwhile, deforestation continues. In bad years, an area equivalent to a small country is cleared within months. Species disappear before they can be named. The knowledge embedded in indigenous languages and traditions and accumulated over centuries of intimate observation erodes, along with the communities that hold it. We are, in the most literal sense, exploring and losing the Amazon simultaneously. And the clock has been running for a long time. We've been moving through places defined by their scale. Vast oceans, polar continents, endless forest. Now, we go somewhere small by comparison, but in some ways, more extreme. A world that descends straight down into the earth, in complete darkness, where the rules of the surface don't apply. Most people picture the ground beneath them as solid, a continuous mass of rock running down toward the Earth's interior. And for the most part, that's accurate. But in regions where limestone geology meets slightly acidic groundwater over millions of years, the subsurface tells a different story. The rock dissolves. Slowly, over geological time, it opens, forming passages, vertical shafts, underground rivers, and chambers large enough to contain entire cathedrals. The deepest cave system currently known to exist descends more than 2 kilometers straight into the earth. That's deeper than the height of most of the world's major mountain peaks. It's called Veryovkina Cave, and it sits within the Arabica Massif in the Caucasus Mountains of Georgia. First surveyed in the 1960s, its full depth wasn't established until the 2010s, and in 2018, a team reached 2,212 meters below the surface entrance, setting a world record. Getting there is not a straightforward expedition. Teams of up to 12 cavers and scientists spend weeks underground, establishing supply camps at different depths, acclimatizing to changing pressure and temperature, and advancing through passages that shift without warning from wide, walkable galleries to flooded tunnels requiring full diving equipment and near-freezing water. The cave is actively fed by rainfall on the plateau above. During heavy storms, some passages flood within hours. Retreat routes are not theoretical considerations. They are survival plans. And yet, despite all of that, researchers keep going back, because what's down there keeps raising questions they hadn't thought to ask. At the deepest sections of Veryovkina, organisms have adapted to conditions that seem hostile to life by any surface standard. Eyeless invertebrates move through the water. Bacteria metabolize minerals in the surrounding rock. The entire food web operates without a single photon of sunlight, drawing energy purely from chemistry. in a system that has been running in total isolation deep underground for an unknown period of time. The cave's full extent remains unmapped. Side passages branch off at various points, many barely entered. Scientists believe flooded sections may conceal passages descending even further, but diving them safely requires preparation that hasn't yet been attempted. Kina is not alone. Nearby, in the same massif, Krubera Cave reaches 2,197 meters, the previous depth record holder. The two systems may connect somewhere below the current limits of exploration. If they do, the scale of what lies underground in that region would be something genuinely without precedent. And Kina may not be the deepest cave on Earth. It may simply be the deepest one we've managed to find and descend. Elsewhere, caves have produced discoveries of a different kind. La Chugilla Cave in New Mexico was considered a modest pit until 1986, when a team broke through a rubble blockage into a vast network that formed not from water trickling down but from sulfuric acid rising up. The result is a cave with formations found nowhere else on Earth and microbial communities sealed off for millions of years. Some bacteria found there produce compounds that show preliminary promise against drug-resistant infections. Life that developed in total isolation, potentially offering tools that medicine hasn't encountered before. In Vietnam, Sun Dung Cave, known locally for decades but not fully explored until 2009, turned out to be the largest cave chamber by volume anywhere on Earth. Its main passage is large enough that internal weather systems form within it. Where the ceiling has collapsed, shafts of sunlight reach the cave floor and support jungle growth inside the cave itself. Ecosystems existing entirely underground, accessible only by descending into the dark. Inside Sundung, there are trees over 30 meters tall, birds, and species found nowhere else on the planet, all of them living inside a cave. Geologists estimate that the vast majority of cave passages on Earth have never been entered. Limestone regions across China, Papua New Guinea, the Andes, and Central Africa almost certainly contain systems of unknown extent. The deepest point any human has ever reached underground is 2,212 meters. Whether the rock continues beyond that, and how much further it goes, is a question with no answer yet. We've gone deep into the ocean, beneath the polar ice, into ancient forest, and straight down into the Earth. But the largest unexplored environment on this planet isn't a single place. It's continuous. It connects everything, and almost none of it has ever been seen. The total area of Earth's ocean floor is roughly 360 million square kilometers. To map all of it in high resolution, the kind that resolves features smaller than 100 meters, would take hundreds of ship years of continuous survey work using current technology. So far, less than 25% has been mapped at that level of detail. Most of it has never been imaged meaningfully. Much of it has never been sampled. A substantial portion has never been observed at all. We have better maps of the surface of Mars than we do of the bottom of our own oceans. The reason isn't a lack of effort. Satellites can't see through water. Sonar surveys must be done by ships moving slowly across the surface, one track at a time. The Seabed 2030 project, an international collaboration working toward a complete ocean floor map by the end of this decade, has accelerated significantly in recent years. But vast stretches of the southern Pacific and deep Indian Ocean remain almost entirely uncharted. And what scientists believe is waiting in those blank spaces is not nothing. Every time a new section of deep ocean floor has been properly surveyed, something unexpected has turned up. Beneath the water, the seafloor is not the flat, featureless plain many people imagine. The mid-ocean ridge system, a continuous chain of underwater mountains running along the boundaries of tectonic plates, stretches 65,000 kilometers around the globe. That makes it the longest mountain range on Earth by a significant margin. Most of it has never been visited. Most of it has never been photographed up close. There are also seamounts, underwater volcanoes rising from the ocean floor, estimated to number in the hundreds of thousands. Scientists believe around 100,000 exist worldwide. A small fraction have been observed, and then there are the vents. In 1977, scientists exploring the Galapagos Rift discovered something that no one expected: hydrothermal vents, where superheated water rich in minerals pours out through cracks in the seafloor. Around them, entire communities of life had developed. Tube worms 2 meters long, blind shrimp, crabs that appeared almost white under submersible lights, and bacteria drawing energy not from sunlight, but from the chemistry of the vent water itself. Before 1977, the scientific consensus was that life required sunlight. That discovery ended that consensus entirely. Since then, vent fields have been found in ocean basins across the planet, each one hosting communities of organisms, many of which exist nowhere else. Scientists now estimate that hundreds, possibly thousands, of vent systems remain undiscovered on the ocean floor. Cold seeps present a different but equally rich ecosystem. Areas where methane and hydrogen sulfide leak upward from the seafloor support communities of organisms, including some of the longest-lived animals on Earth. Tube worms at cold seeps in the Gulf of Mexico have been estimated to live more than 250 years. Deep-water sponges have been found with ages measured in centuries. Black corals discovered off Hawaii were dated to more than 4,000 years old, older than most of recorded human history. The sediment of the ocean floor is also a geological record, layer upon layer of chemical information going back hundreds of millions of years, preserving evidence of ancient climates, mass extinctions, and volcanic events. The vast majority of it has never been sampled. What it might tell us about the history of the planet and about what is coming remains an open question. The ocean we know is its surface. Below a few hundred meters, we are still, in the most honest sense, in largely unknown territory. There's something quietly profound about all of this. We live in a world where almost everything seems documented, photographed, analyzed, where the idea of going somewhere genuinely unknown can feel like it belongs to a different era. To the age of wooden ships and hand-drawn coastlines and blank spaces on paper maps. But the places we've traveled through in this documentary are not relics of the past. They are active, present, and being explored right now. Researchers are designing the next dive into the Mariana Trench. Drilling teams are preparing new attempts to reach Lake Vostok cleanly. Cavers are mapping sections of Veriovkina that no one has entered before. Biologists are cataloging species found last season in an Amazon tributary most people have never heard of. Discovery is not something that happened in the past. It is happening now, in real time, on a planet that most of us think we already know. And what is found in these places matters beyond the fact of discovery itself. The organisms living in the deep ocean trenches, in subglacial lakes, in the total darkness of cave systems. They have already opened new directions in medicine, materials, science, and biology. The understanding that life can thrive without sunlight, under crushing pressure, in scalding heat or near-freezing water, has fundamentally changed the search for life beyond Earth. Every time life is found somewhere we didn't expect it, the possible boundaries of biology expand a little further, and the universe, in terms of what might be out there, gets a little larger. There is still so much of our own planet waiting to be seen. Not in the distant future, not by a generation not yet born, but by scientists and explorers working today, with tools that improve every year, asking questions that couldn't have been framed a decade ago. Our own planet is still, in the most genuine sense, a place of discovery. The ground beneath our feet, the ocean beyond our coastlines, the ice at the bottom of the world, they hold secrets that no human eye has ever seen. They are patient. They are not going anywhere. And neither, it seems, is our curiosity. We haven't run out of world. We've only just started looking.